Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we will study about the assembler directives present in the 8051 microcontroller. We will study that what are these assembler directives, what are their uses, what functions are performed by these assembler directives in the 8051 microcontroller. So let's start with our topic. So let us first understand that what are assembler directives. So assembler directives, they are the statements which are going to direct the assembler that it has to do something. Okay, so like in 8051 we are having instructions, okay, and these instructions are written in the program. So by these, what the instructions do, they are going to perform some specific operation, but the assembler directives, they are different from the instructions. They are not executed or they are not converted into the machine codes. They are just given directly to the assembler. Okay, so assembler is going to do some operation when this assembler directive is written as a statement in the program. Okay, so the speciality of these assembler directive is that they are not being converted into the machine codes. They are directly given to the assembler. They are effective only during the assembly of a program. And they do not generate any code. So the assembler directives, they are just like some statements or some instructions, but the difference is that instructions are converted into machine code, but the assembler directives, they do not generate any codes and they are effective only during the assembly of the program, means they are given to the assembler. And then the assembler is going to perform the operation related with that directive. So let's see that what are the assembler directives present in the 8051 microcontroller. The first assembler directive present in 8051 is ORG. Its full form is originate. This assembler directive is used to set the beginning address of the program, that from where the program is to be written in the memory of the 8051. So to set the beginning address, we will use ORG. Now after this ORG, we will write a number, okay, and this number can be a hexadecimal number or a decimal number. Now if this number is written in decimal, then the assembler is going to convert that number into hexadecimal. So What this originate or org assembler directive does, it allows to set the beginning address, and this address will be written after it in the form of a number. So its format will be org, and then we will have the expression. Example is org 00H. So this number is in hexadecimal and the program will start at the location 0. Okay, so from 00 the program will be written in the memory of 8051. So this is the first assembler directive. Second assembler directive is define byte, DB. Now this directive, it defines the byte variable, okay, that whether that byte, what is the format of that byte variable, whether it is in decimal, it is in hexadecimal, it is in binary, or it is in ASCII format, ASCII code, then that will be defined by this assembler directive. So this directive defines the byte type variable, that the byte is in which format. When the DB is used to define the data, the numbers can be in decimal. The format of the number can be in decimal, binary, hex or ASCII format. Now when the number it is in binary format, then we have to define, we have to write B after the number. If when we are writing B, it means that this number is in binary. So when the number is in binary, whenever B is used after the number. Now if the number it is in decimal, it is in binary, hex or ASCII, then in whatever format it is present, the assembler is always going to convert it in the hexadecimal format. So assembler always converted the number in or byte to hexadecimal format. So the assembler is going to always convert the number into the hexadecimal format. Now if we are indicating the numbers in the ASCII format, okay, so if number is in ASCII format, the characters, they are placed in the quotation marks, okay. For binary we are writing B, for ASCII characters we are writing the number in the quotation marks. So this DB directive, it is the only directive which allows the 8051 to use the string characters, to define the string characters or the ASCII characters in the form of 2 bytes, okay. Now let's see the format of this assembler directive, that how this directive is written in the assembly language program. So first if we are writing DB and then 24, we will write DB and then the number will be there. So DB and 24 is written, it means that it is in decimal. Then if DB 01101111 and then B is written after it, then it means that it is in binary. If DB and in quotation marks the number is written, then it means that it is in ASCII format. If we are writing dB and then 10 and H is written, then it means that it is in hexadecimal notation. So in this way, we can define the byte, the character, and in different formats, in different data types. These are the data types, and with the help of their format we can know that in which representation the number is present. Okay. Now next assembler directive is EQU, that is equate. This assembler directive is used to define some value or symbol. Means we are giving some value to a particular number or to a particular string, okay, to a particular symbol. So this assembler directive is used to give a name to some value or symbol in the program. Value means like we are having 22/7. We know that this is equal to pi. So in the program we will, whenever we are writing pi, then we will use this value 22/7. So we are giving a name to some value or symbol in the program. Okay, suppose that instead of pi, if I have written this symbol, and whenever we are using this symbol in the program, it means that it is equal to 22/7. So I am giving this value some name or some symbol, and we are using this symbol again and again in the program. So it is used to define a constant without occupying a memory location. This will reduce the occupation or the storage in the memory location. Okay. Now its format is name, EQU, and then initial value. Let's take an example. Suppose that we have written fact, then EQU, and then 04H. It means that we have given this fact a value 04. Okay. Now whenever in the program we are using fact, it means the assembler is going to replace this with the value 04. Okay. So this is the use of the assembler directive equate. Next assembler directive is end. This directive is placed at the end of the program. So to terminate the program or to indicate that this is the place where the program has stopped, we are going to write the statement end at the last statement of the program. So it is placed at the end of the source, and it acts as the last statement. So we can say that this directive terminates the entire program. After that, if any instruction is written, then that instruction will not be executed by the 8051 assembler. Okay, and its format is just we are going to write END as the last statement of the program. Now next assembler directive is DS. Its full form is data segment. And And when this directive is written, then it is going to declare a 24 byte of memory location or 24 byte of stack in the data segment. Okay, so declare 24 byte stack in data segment that starts at internal RAM location 08H. So it is going to automatically define the memory location as the 24 byte of the data segment. Okay, and this 24 byte data segment will start from the memory location 08H. Okay, so DS means data segment and its format is just we are going to write DS in the program. Next assembler directive is public and extern. Suppose that in a program we are defining a variable and this variable is to be used in some other file also. So we will define that variable as public and that variable can be used in any of the files in the 8051. So public is used to define a variable for all the files. Extern means if some variable is defined in another file and that variable is being used in some other file. Okay, suppose that in file 1 we have defined a variable A and in file number 2 we are using that variable A. So extern will be used to export that variable from that file. And public means suppose that we have defined a variable A and this variable is to be used in file 1 also, file 2 also, file 3 also. So we will publicly define that variable. So public declares the variable So public declares the variable which is defined in a specific file and that can be used in other source file. Okay, we have defined that variable in one file and now we are using that variable in other files also. Extern declares the variable So it declares the variable that are used in the present file but are defined in some other source file. Okay, so that is the difference between public and extern. Both are used for defining the variables in the source file. Just the difference is that public is going to define the variable in specific file and that can be used in other files also. But here it is defined in the present file but it is used in some other source file. Okay, we are using it in the present file but it is defined in some other specific file. Okay, so these are the 6 assembler directives which are used in the 8051 microcontroller: ORG, equate, end, DS, DB and public and extern. Okay, so these assembler directives, they do not generate any machine code and they are just directing the assembler to do some task or to do something. Okay, so I hope that this topic is now clear to you. Thank you.